In my last video, we defined what polynomial functions are. In this video, we're going to discuss, as a lead up to graphing them, how you would actually evaluate them given certain x values. So recall that a polynomial function is just some function y equals where we have a bunch of x's on the right. Maybe we have like 2x cubed minus x squared plus 4x to the first plus 3. I just made this up. But we'd say I have some third degree polynomial because the highest exponent is 3 and the leading coefficient is 2. What I want to know is what this looks like. So what we normally do is we just kind of make a table of x's and y's and then we go graph them. So our job in this video is to kind of discuss again how would I find something like, if I needed to, f of -2, which was what would go right here. Okay, so there are two ways to evaluate polynomial functions. One is what we call direct substitution. Direct substitution, of course, is the way the first way we learn when we evaluate polynomials. So we're going to say we have some polynomial here, f of x or y. We say y equals is 2x to the fourth minus 8x squared plus 5x minus 7. I want to know what is the y value when x equals 3. So when we talk about direct substitution, what we mean to do is this. We say everywhere I see an x, and this is really important that we're actually taking our time on these. We need to take it out, and what we're going to do is we're going to directly substitute. Okay, so that's why we get its name, direct substitution. We're going to put a 3 in wherever we saw an input field, which was wherever we saw an x. So now order of operations says we should probably do our exponents first. So I get 2 times 3 to the fourth, well 3 times 3 is 9, and 9 times 9 is 81. So I get 2 times 81 minus 8 times, now 3 squared is 9. And I'd say plus 5 times 3. I'm going to go ahead and do that. I want to say 15 minus 7. So now I need to do my multiplication and division from left to right. We say 2 times 81 is 162. Minus, now we have 56 plus 15 minus 7. And we say 162 minus 56. Okay, so 162, let's ask here. 162 minus 56. So we have 162 minus 56, 106. So we have 106 plus 15 minus 7. So 106 plus 15 here is 121. Minus 7 would give us 114. Okay, so we get 114 here. So essentially, if we were to plug in 3 up here, we get 114, which we can already see that when we're graphing these things, it's going to be a little bit difficult to graph points like 3, 114, but also to notice that, yeah, that point's actually on the graph of this function right here. Okay, so what I'm going to share with you is another way to evaluate polynomial functions. Instead of just plugging in that x value wherever you see an x, we could use what we call synthetic substitution. And I notice right here I say another way to evaluate a polynomial equation is by a synthetic substitution. We say it's important to note that the equation must be written in standard form. So the important thing is here, you have to write it in standard form first. And I say with any missing exponents filled in with 0 coefficients. So, for instance, when I say evaluate the function from example 2 at the same x value using synthetic substitution, I'm going to take you through how this works, but I want you to notice this. We were missing an x to the third term. So we say 0x cubed is technically this term. So when we write this out, we say, well, our original function f of x is really equal to 2x to the fourth, 2x to the fourth, let's fix this here, 2x to the fourth plus 0x cubed minus 8x squared plus 5x minus 7. So now, when we use synthetic substitution, the first thing we want to diagnose is this. What is it that we're evaluating for? And in this case, we're evaluating for 3. So if that's the case, what we're going to do is we're going to make what we call an upside down array. This is an array of numbers. And we are going to drop in the coefficients here into this array. So we say this is 2. You have to fill in a 0 here. We say -8, 5, and -7. And what we're going to put out here is this number that we're evaluating for. So I want to make sure we make a note of this. We write x equals. And so we want to know what is the y value that I get when I plug this into my function. So the way this works synthetically is this. You always drop down the first number. So we say carry down the leading coefficient. Okay? And then step 2 is multiply diagonally, add vertically. Okay, so here's what we mean by this. Once we've dropped this down, we're going to take this 3 times this 2 diagonally, and we're going to get 6, and that's what goes up in this next spot. And then what we're going to do is we are going to add this vertically. And so we get 0 plus 6 is 6. So once we multiply diagonally and add vertically, we're going to repeat this until we can no longer do this. So now instead of 3 times 2 and then putting that number here, we're going to take 3 times this, 6, and we're going to put that number up here. We say 3 times 6 is 18. So now we're going to add vertically. Negative 8 plus a positive 18 is a positive 10. Multiply diagonally, so 3 times 10 is 30. 30 plus 5 is 35. 35 times 3, we get, let's see here, it'd be 105. And 105 plus a negative 7 here, let's see, we get 98. So I think that I probably did some math wrong up here. Unfortunately, we say 2 times 3 to the fourth, 2 times 81 is 162. 8 times 9 here is 56. So let's 8 times 9 is not 56 here, right? We'd have 8 times 9 is 72. 72, oh my goodness. Okay, so let's try this again here. If I were to grab my calculator, I'd get 162 minus 72 equals, we say plus 15 right here, and then minus 7. And so you can see that we get 98 here also. So we say 98, and what we're essentially saying is when we plugged in 3, we get 98 per y value. What I want everybody to notice here is this. When you use synthetic substitution, this number right here is equal to f of whatever we plugged in right here, okay? So we say f of 3, or the y value I get when I plug 3 in, is what I get in this very last spot when we do synthetic substitution, okay? So say for instance, I wanted to find now, plug in 4, what would I get for an output? We would say we'd make our array, we'd drop in 2 for this, we'd say, for instance, for this function up here that I'm using, we'd say negative 1, we could put a 4 here and a 3 here, and we'd say, when I plug in 4, what do I get? Well, I'd see, drop down the 2, 2 times 4 is 8, 8 minus 1 is 7, 4 times 7 is 28, 28 plus 4 is 32, and 4 times 32 is 128, and 128 plus 3 is 131. So we would say that I would get 131, and that is sometimes a lot quicker than directly plugging these things into your function. Cheers.